Hello and welcome back. So in our previous segment we talked about what causes pressures, and now we want to talk about another phenomenon that's associated with weather, and this is going to be called the Coriolis Force. So before I lecture on it, I'd like for you to watch this video here. So it says see, and then there's that thing, www.youtube.com, and so type that in on your computer and watch it. It's important. Okay, got it? So what you should have saw was that there were some teenagers that were on a rotating platform, and if the platform was not rotating, the woman in the video could have taken the ball and thrown it directly across the rotating platform to her partner. No big deal. But then what they did was they took that rotating platform, started to rotate it, and then she tried to throw it straight, but what happened was it appeared that it veered off course. Now, in fact, it really did go straight. It was kind of an optical illusion. So do you remember when we talked about retrograde motion? Was if you look at a planet during the course of many months at night, you would notice that the planet is going across the sky, but then it appears to go backwards, and then it appears to go forwards again. And we said that that was an optical illusion that was caused because one planet was passing another planet in its orbit, and it made it look like it was going backwards. A similar effect is going on here, that the object really was going in a straight line, but the platform was rotating out from underneath it. So it made it look like it bent in midair when it really did not. Now the Earth does the same thing. So if you could imagine a wind, let's say the wind is starting out at let's say the wind is starting out at the equator, and it's trying to go to the North Pole, so it's going in a straight line, but the Earth is rotating out from underneath it. So then it would appear that that wind is going to veer off course. And in the northern hemisphere, winds are going to bend to the right. In the southern hemisphere, winds are going to appear to bend to the left. And there's a formula for it. So if you look at that formula, that's the Coriolis formula, or for the Coriolis force. And let's just look at what letters are in that formula. So you should recognize the letter M. So that stands for mass. So that would be the mass of the object that is trying to move on a rotating object. Okay, V is going to be the speed of the object. Okay, then that T-like thing, so it's not T, it's tau, so it's one of these things. So that's the Greek letter T. That's period. So that's going to be how long does it take the planet to make one complete rotation. And then you'll notice it also has another letter that looks kind of like this. Okay, and so what that means, that's the Greek letter theta, and that stands for angle. And so that's going to be the latitude at which you're measuring the Coriolis force. So the strength of the Coriolis force depends on where you're at on the Earth's surface. Now you also notice it says sin of the angle, and so that comes from trigonometry, and so that's the trig function sine. So you would actually read it as 4 pi m times v times the sine of the angle divided by the period. Now, don't get all worked up about that. Okay, so what I'm just saying is that the strength of the Coriolis effect depends on how fast is the object spinning, and by using the formula, you can even predict that the faster something is spinning, the greater the Coriolis effect is going to be, the more the winds are going to want to turn. And then also, the faster the winds are blowing, that's going to be the V, the more they're going to want to turn. And then it also depends on where you're at on the surface of the planet. So at the equator, it turns out that the theta is going to be a 0. So 0 latitude when you're at the equator. And the sign of 0 is 0. So that you don't feel the effects of the Coriolis effect on the equator. But as you start to move towards the north or the south pole, the effects become stronger and stronger because of that formula. Who cares? All right, let's take a break, and then when we come back, we're going to apply the Coriolis effect to the Earth.